right, let's go on page 84 when we're done. Okay, so a lot of what we're going to do today is a review from the trig stuff that I've sprinkled in this semester. But even with the review part of it, some of the vocabulary might be new because I didn't really put all that vocabulary there. It would have just been too much. And that's kind of what we need to be focusing on, because then you're going to be looking at these questions from the angle of the exam and not just me asking you what angle measures are. All right, so in this course, we're going to approach angles in a way that may be different than you've seen in the past, but not different than you've seen this semester. We'll approach angle in a generalized method that allows us to view them through a periodic lens. To do this, we must make a few clear definitions. So this part's definitely a review. So we've got standard position. Standard position in the coordinate plane for an angle, you have an initial ray that is on the x-axis. Initial ray. Okay, that's where we start. We start on the x-axis. And then, so standard position, vertex is at the origin. One ray lies on the positive x-axis. Then the other one is called your terminal ray. That's the one that spins around. Okay, that's your terminal ray. And that's your standard position. Okay, everybody good with that? So remember, if we have a reference angle, like if this would be my reference angle, that angle's not in standard position, and that's okay. But we also don't have angles that are just floating around in outer space, like they're attached to the origin no matter what. All right, so sine, cosine, and tangent, which we are pretty familiar with at this point, but we're going to talk about them first, not on a unit circle, just in general. So given an angle in standard position and a circle centered at the origin, there's a point P where the terminal ray intersects the circle. So here's point P right here. Okay. So here's my angle. Let's go ahead and draw that in. Hello, thank you. Now here's where our terminology changes a little bit. Doesn't change. I mean, it's the same. It just probably gets a little bit more formal, or you probably haven't heard it this way, I guess is what I'm trying to say. So sine of theta is the ratio. So it makes a fraction. We know that. We even have talked about the fact that it's y over r when it's not just a unit circle. But look at the rest of this. It's the ratio of the vertical displacement of P from the x-axis to the distance between the origin and point P. Okay, so let's think about that. We know that sine is y over r. So here is y, right? And we've talked about the fact that that is the distance from the x-axis, right? The radius is the distance from the origin. But look at the terminology it uses up here. It actually says vertical displacement and then distance between P and the origin. So it doesn't say distance both times. One of the times it says displacement. Who can tell me the difference between distance and displacement? So you know, but you can't put it in words. I'm with you. Displacement is how far away you are from the origin. Yes. Yes. Okay, it is, but like so is distance, right? Okay. So so I'm trying, because I think y'all know. I'm just trying to get it out of you. So P, from P to the origin, the radius, that's the shortest distance from there, right? And it says distance here, not displacement. Y'all were discussing, what were we discussing? Give me something, I can get you there. What were you thinking? You don't want to talk, you want to tell me? You weren't thinking anything? Ah, well, good. That's what, it's physics, yes. Anybody in AP physics? Do I need to call Mr. Anderson? No, don't call him. Okay. All right, let me tell you, because I think y'all know, I think you can't put it in words, okay? Here's the difference. Distance is, okay, can I drive a -5 miles? No, I cannot. So distance is always positive, all right? Displacement could be positive or negative. Okay, does that make sense to you? So so this y here, because my y can be positive up here, it'd be negative down here. So the vertical displacement, if I go up, it's positive. If I go down, it's negative. But when I draw my triangle in there, if I like take the right triangle out, even if the right triangle was down here, all the lengths are positive, right? Because it's the length of the side of a triangle, but the displacement is actually negative. So there's a little physics lesson if you didn't know. Again, I think some of y'all do know. I just think sometimes, like if you had to do a question, you would do it right, but you can't put it in words. So you're good. I won't call Mr. Anderson, I promise. So why? So I just want to make sure, because these words are going to be in some of the multiple choice questions, so I don't want you to get lost in the words. So although why, we do think about it as a vertical distance, and we use the word distance even when it's negative, it's not proper, but what it really is, this is the vertical displacement. Okay. So if you're in a boat and you go parasailing, you're going up, like you would say my displacement is positive. If you go scuba diving, then that's when your displacement is negative, right? Because you're going under the water, depending on where you're measuring from. All right, so then we're also going to label here the radius. This is the distance between origin and point P, because the radius is always positive. That's why we call it the distance. It's always positive no matter what. The X and Y could be negative or positive. That's why we talk about them as displacement. Okay. So then when we get here, we've got cosine, it's the ratio. So we got the fraction, right? Horizontal displacement of P, distance between the origin, because that's R, right? So my X, this is the horizontal displacement. Because using all these words in a sentence in a multiple choice question can make things sound way more complicated than they really are. So I want to make sure you understand that you do understand this, right? It's not any harder than what we already knew. It's just different words in there is all it is. Okay. And then tangent. Now with tangent, this is kind of a new thing that's getting thrown in there, and this is super important. Okay, so we're going to skip over the first sentence for just a second and restart here. So tangent is the ratio, so we know that we're making a fraction again. Vertical displacement to the horizontal displacement, and that's just y to x, right? And we know already that tangent is y over x or sine over cosine. That hopefully we know from what I have sprinkled in this semester. The first part of this is the part that we got to make sure we understand is true, because that could totally be in one of the questions that, and if you don't understand that concept, it makes it a really difficult question. But if we understand that, it makes it really easy. So this says that tangent of theta is the slope of the terminal ray. So this is my terminal ray right here, right? So if I drew in, see if I can do better than I did last period. If I drew in a dotted line, that looks a little straighter. So that my orange line, okay? My orange line has a slope. Not only does it have a slope, it has a positive slope, but it's also the same slope as the terminal ray. Would y'all agree with that? And this point is xy. The way you find slope is the change in y over the change in x, right? Because I'm going through the origin, it basically is just any y over x. So the slope of this orange line is my tangent value. It is y over x. And that also can help you understand why tangent, see, this is a positive slope, right? Tangent is positive in the first and third quadrants. If I have a line go through this way through the origin, like I don't want to draw it in because I don't want to confuse things, but if it goes through there, then that slope is negative, right? And tangent is negative in the second and fourth quadrants. Okay, so just think about the slope. The slope is the tangent value. Okay, we're going to need to make this connection right here. Okay. Everybody okay with that? Any questions at this point? All right. Okay, so here we go. This is something you can see directly off the exam. It says, and don't skim over the questions. Actually read them, even though sometimes they sound like they say the same thing over and over again. The figure shows a circle centered at the origin, angle of theta. I see my theta in center position. The terminal ray of the angle intersects at point P. The coordinates of P are x, y. Which of the following is true about the cosine of theta? Okay, so before I look at anything, I'm going to think, what do I know about cosine? I know for a unit circle, it is just the x value. Is this a unit circle? And how do we know? They didn't tell me here, but it's not a unit circle. How do I know that for sure? The x value. See this ordered pair right here? Right? So what is the radius of this circle? 3. This is 3 because it tells me that. It didn't tell me that in words here, but it tells me that right here. So this is 3. I could probably also figure it out from my answer choices, but I'm just saying, like, we got to make sure that we understand what's going on up here. So then I know that the cosine of theta, not in a unit circle, is x over r. Then I also know that r is 3, so it is x over 3. So if I look down here at these answer choices, there's literally only one that has x over 3. I mean, these two have y's. We could knock those out quickly. And then hopefully we would know it was a based on that. But it's possible that this one could also, like, let's just pretend that this said x over 3 so that I could not just eliminate it, right? Then I have to read the words because it is the ratio of the horizontal displacement, that's my x, to the distance between the origin and P, that is r, right? The ratio of this to this, that gives me x over r. Where here, if I read these words, it's the ratio of the distance between the origin and P, that's r, to the horizontal displacement, that's x, that would give me r over x. Does that make sense to you? So you got to make sure you can get the words right. And that you know, so you don't read horizontal displacement and go, what the heck is that? I think hopefully we get it now. We okay so far? Because I know not all of us have even had physics, and that's probably the first time you talk about it. Maybe, and I don't know. I'm not even gonna pretend I don't even know anything about your science classes. But all right, so the figure shows a circle with radius 5. So here, this time it told me radius of 5. Centered at the origin with an angle measure theta in standard position. The terminal ray of the angle intersects the circle at point P. So here's point P. So here's my initial ray, and here's my terminal ray. Right, so this is my angle right here. Find the following values. So this is my theta right here, right? So I need this ordered pair. What do you think this ordered pair is? You think the x value is? 3. What would the y value be? -4. And it's not just because I have a random point up there, but because this is a perpendicular line here, this is just a straight up reflection. And that's how I get that ordered pair. And then I know that my radius is 5. So then I can find these. I know that sine, we'll just write this down one more time, y over r. So that means that's -4 over 5. Cosine of theta is x over r. Whew, that's an r. And that equals 3 over 5. And tangent is y over x because it's the slope, right? Just like slope. And that equals -4 over 3. Okay. Any questions at this point? We all good? All right, so grab your next sheet of paper. This is going on page 84 as well. Okie dokie. So this says, the figure shows a circle with radius r, centered at the origin with an angle measure of theta in standard position. The terminal ray of the angle intersects at point P. So here is my angle that it's talking about. Here is theta. The coordinates of P are x, y, and they're already labeled for me. Points Q, R, and S are the result of reflecting across the axes, right? So then what would the ordered pair for Q be? If P is xy, Q would be -xy, right? R would be -x, -y. And S would be x, -y, right? And part of that is because we understand how the quadrants work too, right? So that's all we're asking for in terms of x and y. So we can go ahead and fill these in. This is -xy. this is r, so that's negative x, negative y, and x, negative y. Okay. We're all good with that? Just like the reflections that we had already talked about. All right, so then it says, find the sine of the angle whose terminal ray intersects with point S. Okay, so we can't call it theta because we already have a theta. So let's call it alpha. So we're going to find the sine of alpha. Point S, sine is y over r. So S is right here. That's a negative y. So it'll be negative y over r, which makes sense because that's in the fourth quadrant and sine should be negative, right? All right, so then I want cosine. Well, I can't call the angle theta or alpha because I already have those. So let's use beta. That's usually the next thing that gets used after alpha, then beta. And we're looking at point Q. So this is cosine. So when I look at Q, I want the x value, right? Look at Q, that's a negative x over r. So we've used theta, we've used alpha and beta. So usually the next one, which we won't come across too much, but just because I want you to at least have seen these things, is gamma. Now my gamma is not going to look that good, but you know, it's okay. We're attempting. Tangent. So gamma, I guess my description of it would be like a tall, weird looking lowercase r. Like, you know what I mean? Like it's been stretched and deformed, but that's kind of gamma-ish. Good enough. All right, so then point R, where is point R? Point R is negative x, negative y, so tangent is y over x, so it's going to be negative y over negative x, and that's going to give me just y over x. Now I'm going to have you draw one more thing up there because I've kind of gone back and forth on whether or not even I wanted to do this, but I went ahead and scooted that picture over because I have seen this come up once, so I just want to go ahead and make the point. So this is extra. It has absolutely nothing to do directly with these questions, so I don't want it to confuse you. So just draw a circle to the best of your ability, and we'll put the little x and y axis in it. It's okay if it looks like an egg. You'll get the point of what I'm trying to do here. So let's say that we have this point right here, okay, that I have this point here. And they say this point A, whatever it is, point A is the ordered pair XY, okay, which is perfectly okay. I know that in the second quadrant, the X values are negative. Well, in this case, then X would just be a -3, right? That makes sense. It's still an XY. So if I have that point and that point is XY, and then they ask me for this point, which is B, let's say, even though I know in the third quadrant it's negative x, negative y, based on this, that wouldn't make any sense. So here for this one, the x value is the same and the y value changes. Does that make sense to you? I don't think that those things occur just to like try to confuse you, but if we're always just thinking about the quadrants and they throw something in there like that, and you're not really thinking about how it would relate in that case, then that could be a problem. Okay, so that's why I just wanted to at least address it. And then if it comes up in an actual question, I'll make sure and talk about it again. But all right, so let's go back down here. It says, let theta be an angle in standard position whose terminal ray coincides with the line y equals -3x in quadrant 2. Okay, so let's draw us a little picture here. Let's go ahead and, I don't have to be beautiful, but there we go. And so at quadrant 2, so I don't have to have the angle of the line perfect, but it's something like that. Okay, so there's my line. And I want to find the following values. Well, one of those three values I can write down like that. They have given me the equation of a line. Which one of these three relates to something in a line? We talked about it on the front page. Tangent. And tangent is what part of the line? The slope. What is the slope of this line? -3. So tangent of theta is -3. It is just the slope of that line. Okay? So now if I want to get The rest of this, I've got to know some other stuff if I want sine and cosine. So if I draw in my triangle right here, I know that tangent is y over x, so this could be negative 3 over 1, right? And so my y would be 3, my x would be 1. One of those two is negative. Which one? The x, yeah, the negative one right there. So then I'm going to take that triangle out here, and this is 3, negative 1, because that's a displacement, and then this is my r, right? I need to figure out what the radius is so that I can do sine and cosine. What do I do to figure that out? Pythagorean theorem. So 3 squared plus negative 1 squared equals r squared. So that means that r squared equals 10. When I take the square root, technically I get plus or minus, but your radius is always positive, so I get the square root of 10. So you go ahead and set up sine and cosine and fix your answers correctly. And while you're doing that, I'm going to hand out the next set of notes, because I told you I'm going to bombard you with paper today. Okay. So sine y over r, so that's 3 over the square root of 10. Cannot leave it like that. I have to be able to rationalize accurately and efficiently, and that becomes 3 square roots of 10 over 10. Cosine is going to be negative 1 over the square root of 10. That becomes negative square root of 10 over 10. Okay. Any questions at all? Except how to rationalize. If you don't know how to rationalize, go back to the summer assignment you didn't do, find where you're rationalizing the denominator, and learn how to do it. It's a prerequisite skill. Okay. All right. Grab your first part. I just passed out 2 pieces of paper, so make sure you get the first one that looks like this, and this is going on page 85 when we're done. So now we're talking about the same kind of stuff, but mainly with the unit circle now. So again, most of this is a review. Just kind of quickly talk through it again. It reminds us about standard position and terminal rays. I think we got that at this point. Oops. So here's my angle, right? This is theta. I think we're good on that. Positive and negative angles. Pretty sure we're good on that too. Just going to remind ourselves real quick. Positive and negative is just the direction. So positive angles go counterclockwise. Negative angles go clockwise. I know you can't actually read that clock, but I hope you at least know which direction the hands go in, because that can help you. And then this denotes a positive angle because it's going counterclockwise. Okay. All right. So since we are using the coordinate plane to define angles, we consider angles to have periodic behavior. Angles in standard position that share a terminal ray differ by an integer number of revolutions. So what that means is this. I have this angle right here. I could go from here directly to here. Or I could go from here, go 1 full rotation and then land there. Or 2 full rotations and then land there. So that's what it means by it differs by a number of revolutions, because we could keep spinning. We end up in the same spot, but maybe one's more laps or whatever. Okay, so today we will measure angles, or the way we will measure angles throughout this course and in future courses may seem a bit strange at first, but this isn't the first time you're seeing it. We're going to talk about radians, right? So the radian measure of an angle in standard position is the ratio of the length of the arc of the circle centered at the origin to the radius. So it's arc length over radius. That's what gives us radians. And in a unit circle, the radius is 1. That's when the arc length and the radians are just exactly the same. Okay. What we have to know, and you have to know, the circumference of a circle is 2 pi r, and then we can find the arc length considering the ratio of the circle's circumference. So I can find the whole thing. If I only need half of it, I take half the circumference. That's my arc length, okay? So it's all related to arc length. That's why you talk about it first in geometry, okay? So flip this over. We kind of already know this answer, but we're going to pretend like we don't so we can go through the process, because we may be given a question like this for an angle we don't just know, okay? So it says, consider theta created by the quarter circle with radius 4 above. I'm going to find the measure of theta in radians. So remember that, like there's something else. Oh, I guess not. Okay. Remember that theta is equal to arc length over the radius. So in order for me to find arc length, I have to find the circumference. So I'm going to start with circumference is 2 pi r. What is the radius here? 4. So it's 2 times pi times 4. Circumference is 8 pi. There you go, right? Piece of cake. So I've got my circumference. Then I need to find my arc length. Now, this is not the proper way to abbreviate arc length, but I'm going to do it anyway. We'll say AL for arc length. I mean, at least it makes sense. There's not really a good way to do it. So arc length is equal to, well, I don't want the whole circumference. How much of the circumference do I want? A fourth of it. So I'm going to take 8 pi and divide it by 4, because I only want a fourth of it. Not because the radius is 4, but because I want a fourth of it. That gives me 2 pi. So this arc length right here, the arc length is 2 pi. Clearly not the angle, right? But it's the arc length. So then to find theta, theta is the arc length, which is 2 pi, divided by the radius, which is 4, and that reduces to pi halves. And theta is pi halves, and we knew that because that was at 90, right? But that's how you get it when it's not a unit circle. You have to find the arc length and then divide it by the radius. Okay. Questions about that? Okay, let's do another one. It says to find the measure of the angle formed by a third of a circle with radius 3, and this says in a clockwise direction. So in the end, my angle is going to be negative. I don't have to worry about it till the end. But I need my circumference. That is 2 times pi times the radius, which is 3. So that gives me 6 pi. Then I need my arc length. My arc length is going to be 6 pi, but it's a third of a circle, right? So I'm going to multiply it by 1/3, and I get 2 pi again. You will not get 2 pi for every arc length. Just going to throw that out there. So then theta is my arc length, which is 2 pi, divided by my radius, which is 3. So I get 2 pi thirds. But it says clockwise direction, so it's a negative 2 pi thirds. Okay. What questions do you have? Anything? Okay. So then we're just going to state what the unit circle is again. Center at the origin, radius 1. I could have taken some of this out because it's repetitive, but I thought sometimes it's good to hear it over and over again. For a unit circle, the radian measure is the same as the length of the arc because the radius is 1, right? So the concept of the unit circle will become pivotal throughout the rest of this course because of its incredible usefulness. Not just the rest of this course, but in calculus as well. It is not going away. So embrace it, learn it, love it, understand it, and if you really get it down, you'll just know it, and it's not that big a deal. Okay? All right. Next piece of paper then. Let's go on page 85. So for each of the following, we're going to sketch a picture of the arc length described based on the unit circle, then find the measure of the angle corresponding to the given arc length. So really, we're going to kind of do that backwards. I would rather find it and then sketch it, but we're going to sketch this. I want 1/6 of a circle, and this says based on the unit circle, right? So the circumference of a unit circle is 2 pi. But I only want 1/6 of it, so I multiply 2 pi times 1/6, and that gives me pi thirds. Okay. What is pi thirds in degrees? 60. Pi thirds is pi fourths is 45. Pi thirds is 60. That just helps me kind of put it in the right spot. And so this right here, theta is pi thirds. Okay. 2 full revolutions in the clockwise direction, which means it's going to be negative, right? So that means I'm going to take 2 pi, I'm going to multiply it by 2. That gives me 4 pi. But theta is actually negative 4 pi because of the clockwise part of that. So to show that angle, here's my initial ray. I'm going clockwise, and so I have to go around once and then twice, and then I get to stop there, and theta equals negative 4 pi. Okay, everybody good with that? All right. Then we've got 3/4 of a circle in the counterclockwise, so that means it's positive, so I don't have to do anything, worry about that sign in the end. So I'm going to take 2 pi, multiply it by 3/4. What's that going to give me? 3 pi halves, yes? 6 pi over 4, 3 pi halves. What quadrant is that in? It's quadrantal. Their 3 pi halves is down here, right there. We good with that? All right, so then 7/8 of a circle. So 2 pi times 7/8, what's that going to give me? 7 pi over 4, yes. What quadrant is that in? Fourth. Okay, so the fourth quadrant, and pi fourths in degrees is what? Just pi fourths. 45, right? So I'm in the fourth quadrant, pi fourths is 45, so that tells me I'm going to go halfway right there. That's what helps me there. Because remember, this would be 8 pi fourths, and I back up 1. That's where I'm getting that. So theta is 7 pi fourths. If you feel like you're getting a little rusty on some of those, all those delta maths I gave you where it was asking you those questions one after another, you can always go back and do more questions. Like, I leave it open so that you can go back and do more if you want to. I know you're not going to go back and redo everything, but some of the trig stuff, it's a good way to practice. Okay, so we're going to do this quickly together. I was going to give you time, but I'd rather have more time to talk about stuff because we've done this a lot. It might take you another second because we haven't talked about it in a while, but let's put in our angles. We're going to go 0, pi 6, pi fourths, pi thirds, pi halves. I think no matter what, at this point, I think you're experts on that part, right? So then I reflect. Pi thirds, this is 2 pi thirds. Then this is going to be 3 pi fourths. And then this is going to be 5 pi sixths. Then this is pi. Then I start back with my sixths. This is 7 pi sixths. Then this is 5 pi fourths. And then this is 4 pi thirds. 3 pi halves. Right? And then I remember these as 5, 7, 11. So I'm going to put my pi's on there. So that's 5 pi thirds, 7 pi fourths, 11 pi sixths. Okay. We good with that? Hopefully if I gave you some time, but again, I think we can do it. So I just wanted to be able to move on. All right, so now we're talking about sine and cosine again. This looks similar to what we did on like one of the first pages, but this is with the unit circle, okay? So for a unit circle, we know the radius is 1. The sine and cosine values are simplified. This is where we know that because it's a unit circle, and I know that for sure here because of this 1, even if they don't tell me, then sine of theta is just y, cosine of theta is just x, and then tangent is what it is, right? It just stays the same no matter what. So when we look at this, and this should be a fairly simple question because we already did all this unit circle stuff. This says the figure shows a...
Eruption is just a reminder, we're going to map time. Also, teachers got a little special surprise for you during all 4 lunches in the Teachers Lounge. We have Texas State Teachers Association that just wanted to say thank you for everything that you have done. So there'll be some sandwiches available for our teachers in the Teachers Lounge during all 4 lunches. Thank you.
Okay. The terminal ray of the angle intersects the point at point P, and those are the coordinates, right? So we're going to find the following values. So we know this, right? Sine of theta. What is the sine of theta? They gave me the ordered pair. Is it x or y? Y, so it's square root of 3 over 2. What is the cosine? 1/2. Now, I could figure out tangent by doing the fractions and stuff, but I don't need to, because what is this angle measure? We should know that if these are the values I have. 60, so this is pi thirds, right? So then what is the tangent of pi thirds? Square root of 3. Okay. This will be much harder had we not done all that other stuff already. So before I scroll, it says the point R is the result after point P is reflected in the y-axis. So this is R. Okay. Let alpha be the angle in standard position. So that means here, this is alpha. What is this ordered pair then? Negative 1/2 square root of 3 over 2. Yes? All right. Y'all answer those questions down there while I hand out your assignments, and then we'll talk about them real quick. And I do have 2 assignments for you because it's technically 2 parts. Yes, they are both stapled like huge packets that are going to hurt your back to carry around. But the questions are ginormous. That's why there's so many pieces of paper. Killed a lot of trees for today, just for you. Okay. So then we know, since we are in the second quadrant, sine is going to be still square root of 3 over 2. Cosine was negative 1/2, right? What's tangent? Negative square root of 3. Okay? We all good with that? Awesome. So these questions on this assignment, some of it is just asking you some simple things like I had before, but they're also more in the wording of the exam, but same type of information, okay?